It is estimated that around 6% of the American population has type O negative blood, the universal donor type for red blood cells. It should be noted that type O negative is considered the most universal donor type for red blood cells. Actual compatibility must be evaluated on a case-by-case basis. But suppose a blood bank administrator is attempting to predict the amount of O-negative blood that will be donated on a given day. If there are 200 donors on a given day, how many can be expected to be type O-negative? So the first thing we need to do is decide whether or not the criteria for the binomial distribution is satisfied. The first is that we would have only two possible outcomes. And in this case, we either have someone with O-negative blood or not. So we only have two possible outcomes, and what we'll do is consider a success finding someone with O-negative blood. Another criteria is that we would have only n independent trials, so a finite number of independent trials. Trials for which the outcome of one trial does not affect the outcome or the probability of a success for the next trial or the next trial or the next trial, and on and on. And in this case, that is true. We have 200 independent trials if these people are selected randomly. The next is that a probability of a success is consistent from trial to trial. And in this case, that's true. We're told that 6% of the American population has type O negative blood. So the probability of a success, P, is going to be 0.06. Now the question says, if there are 200 donors on a given day, how many can be expected to be type O negative? Well, the expected value for the binomial distribution is the same as the mean and is calculated by multiplying the number of trials by the probability of a success. So we would have 200 times 0.06. So this mean then, or this expected value, would be 12. So we would expect 12 out of those 200 to have type O negative blood. What is the probability that exactly 20 would be type O negative? In order to calculate probabilities for the binomial distribution, we find them by the formula, the probability that x is equal to some k number of successes is going to be n factorial divided by k factorial times n minus k factorial times p raised to the k times q raised to the n minus k, where q is, of course, 1 minus p, the probability of a failure, or the complement of p. So the probability that x would be equal to, and here it says 20, exactly 20, so the probability that x is equal to 20 is going to be 200 factorial divided by 20 factorial times 200 minus 20 factorial times 0.06 raised to the 20th power times 0.94 raised to the 200 minus 20th power. And that probability is going to come out to be 0.0086 if we round to 4 decimal places. Now we can use StatCrunch to find this probability quickly and easily. We'll do that by clicking Stat, Calculators, Binomial, set n to be 200, p to be 0.06, and then the probability that x is equal to, and the value was 20. And again, we find this probability 0.0086 if we round to 4 decimal places.